All right, next example, we're going to be integrating the function x squared over the region E, where E is inside x squared plus y squared plus z squared equals 36, and above z equals negative root 3x squared plus 3y squared. Okay, so let's see, easy, that's a sphere, and then maybe hard, what's that? Okay, well, that looks a little bit like what we had last time, which was z equals the root of x squared plus y squared. Except we're multiplied by negative root 3. Z equals negative root 3 times the root of x squared plus y squared, right? And z equals the root of x squared plus y squared was this cone that was 45 degrees. Okay, so if it's negative, first of all, it gets reflected, so it's in the bottom, beneath the xy plane. And then multiplying by root 3 just stretches it out in the z direction. Root 3 is about 1.7. So instead of 45 degrees, it's going to be more angle from there, or less angle from the z-axis, whichever way we look at it. And actually, this thing we stretch by, that's the slope. So we can think of that as being a line of slope, whatever slope means in 3 dimensions, root 3. One way we can think about a cone, one way a cone is defined in math, is you take a line and you rotate it in space. So that the generating line of the cone has slope root 3. And if you had a good pre-calculus class, they taught you about conic sections as actually cutting things out of a cone. But most pre-calculus classes did not do that. Anyways, it was a long time ago. Even if you had a good one, maybe you don't remember. Okay, so slope root 3. What does that mean? That, if you have a slope of root 3, that seems like a pretty familiar number, right? You can think of this triangle. I think the triangle we should be looking at is 1 root 3 too. A lot of people teach it as this other one. So root 3 over 2, 1/2, 1. They're similar triangles. One is double the other one. So the angles are the same. So it doesn't really matter, but that's an easier triangle to remember. So I think we should think of that one. And then it's very clear that the slope of that line is root 3. So the angle there is pi over 3, or 60 degrees. And then the angle it makes with the vertical here is pi over 6, or 30 degrees. Okay, and then for those of people who prefer to have a formula, what we're really doing is we're taking the arctan of root 3 to find this angle down here. Arctan and tan inverse have been going back and forth. It used to be, this was popular like in the 70s and 80s, maybe early 90s. This grew into fashion a lot. We're going a little bit back towards arctan. I'm not sure who's going to win. They mean the same thing. Right now, I would say be comfortable with both. Okay, so we figured this out. This is a cone. It's a steeper cone than before, and because of the negative, it's the bottom half of the cone. And then inside this other thing, that's a sphere of radius 6, of course. So we'll just pretend it comes up to here. Okay, so we want this upside down ice cream cone region. Okay, so that pi over 6 is going to be really useful to us. Okay, let's see. We have 3 integrals. We have x squared. Remember, x was rho sine phi cosine theta. Okay, so x squared is going to be a lot. Rho squared sine squared phi cosine squared theta. And then because I'm integrating in spherical coordinates, I need another rho squared sine phi. That's abysmal. D rho, d phi, d theta. Okay. And now what's happening? So rho is going from 0 to 6 because I've got my sphere of radius 6. Phi is going from, okay, so if that red angle there is pi over 6, then, and phi is the angle with the positive z-axis, so that must be 5 pi over 6. So phi is going from 5 pi over 6 up to pi. That's what happens when we start taking negative values of z. So your values of phi are going to be pretty big, pretty close to pi. And then we're still going all the way around, so theta goes from 0 to 2 pi. Okay, I'm going to clean this up a little and then integrate. So these are a lot of work. Triple integration, 3 times the work of regular integration, right? And we thought regular integration was a lot of work when we first started. Okay, so rho to the 4th, we have sine cubed phi and cosine squared theta d rho d phi d theta. Okay, and then you just got to integrate 3 times. Nothing too much more clever. The thing I wanted to show you here was the cone with slope root 3 and how to find that angle. So I've shown you that. The only other thing that you may or may not remember, so you know how to integrate an odd power of a sine or cosine. We talked about that in a previous video. Leave one sign there, replace it, the sine squared with 1 minus cosine squared, do a u sub. You may or may not remember how to do an even power. That's going to use this other double angle formula that I encourage everyone to memorize. I know you can look it up, but if you memorize it, then you can recognize it walking down the street. If we rearrange this, we get cosine squared theta is cosine 2 theta plus 1 all over 2. And then now we know how to integrate this thing with a little bit of easy chain rule. Okay, so play around with that, integrate it yourself. I think the answer that you get is a little bit more than 83, probably closer to 84. If you want to check your answer, then that should help you.